Algebra 2, what's going on? Okay, today, section 8.3, we're working on graphing 1 over x. Okay, we're going to start off by determining the values of x for which each function is not defined. Alright, so we start off easy here. Okay, remember what makes a function not defined is if it equals 0 in the denominator. So we need to figure out when this would equal 0. So when does 2x plus 3 equal 0? We're going to subtract 3 and divide by 2, and we'll get negative 3 halves, or a negative 1.5. Okay, why don't you take a second here to think about that one. Alright, so you should have 3x minus 1 equals 0. We're going to add the 1 over and then divide by 3. 1/3 would make that equal 0. Okay, so these things that make it equal 0 on the bottom that cause the function to not be defined at those individual points, those domain restrictions will lead to vertical asymptotes. Okay, they're imaginary lines that our graph will get closer and closer to but never cross or touch. Okay, an example, just a rough sketch here of one. If we had 2 over x minus 1, okay, if x was 1, we'd get 0 down here, so I know x cannot be 1. That is where there'll be a vertical asymptote. Because if I can't go straight across, because if x did equal 1, we'd have 0 in the denominator, we get an error. So that's what causes this imaginary line or vertical asymptote to happen. Okay, we also have an asymptote going side to side, a horizontal one, and we'll talk more about those in just a second. Okay, so just a basic graph of 1 over x. There's our basic info for 1 over x. Okay? It has a vertical asymptote at 0, at x equals 0. And it also has a horizontal one at y equals 0. Okay, let's think about why we'll have these asymptotes. Okay, we know why we're going to have the vertical one, because we can't divide by 0. If I put 0 in there, we'll get an error. And even though this is the y-axis, this is also where x equals 0, right here on this line. What about these horizontal ones? What's going on as I put in numbers in for x? If I put in a 1, 1 divided by 1 is 1. If I put in a 10, 1 divided by 10 is going to be 1/10 or 0.1. Pretty small down here. If I put in 100, 1 over 100 is 0.01. It's going to get even smaller. Okay, and I can keep dividing by bigger and bigger and bigger numbers, and it's just going to make my resulting decimal be smaller and smaller and smaller and smaller. Okay, it won't ever actually get to 0, but it will get really close, and that's why we're going to have a horizontal asymptote here. We're going to keep getting really close to 0, but we're never going to touch it, and we're never going to cross it. Okay, kind of think about it the other way, is I keep dividing by smaller and smaller decimals. Okay, 1 divided by a half, or 0.5, is going to give me 2. 1 divided by 0.25 is going to give me 4. 1 divided by 0.1 is going to jump me up to 10. If I keep dividing by smaller and smaller decimals, that number is going to get bigger and bigger and bigger going up. Okay, but I can't divide by 0, so I'll never quite get there, but it'll keep getting bigger and bigger this way. Now how do I get down to this curve? Well, 1 divided by x, what happens when I put in a negative number? What happens if I put in negative 2? 1 divided by negative 2 is going to be negative a half. So we'll go to negative 2, negative a half. So that's why this piece is down here, is that I'm dividing by negative numbers. A positive 1 divided by these negative numbers is going to get me another negative, so my answer will be down in here. And we can do the same kind of thought process. If I take 1 divided by like negative 100, it's going to be a really small negative decimal. Going to get really close to 0, but never quite get up to it. And if I divide 1 by negative 0.00005 or something really small negative decimal, really close to 0, it's going to give me a really big negative number way down here. Alright? Just like with any other graphing section we've done, we've also learned how to do our translations and make adjustments. Okay, we have the same letters representing pretty much the same stuff as we've had the whole time. So now our A, our stretch, shrink, multiplier is on the top of that fraction. X minus h, we'll put parentheses around that, is on the bottom of our fraction. And plus k is on the back side, as it usually is. Okay? So h, it's inside those parentheses there with x. That's going to shift things left and right. And most noticeably, it's going to be the vertical asymptote is going to get moved left and right. Remember, if it's inside parentheses, it's opposite of the sign, opposite of what you would think. So if it's a minus 5, you think, oh, minus 5, that's negative, it's going to go left. Really, because the minus is already built in, when you see a minus 5, it's really a positive 5, it's going to push it to the right. So if you see a minus 5 in here, it's going to go to the right. If you see a positive 5, it's going to go left. Opposite of the sign. Our plus k on the back side is going to do any vertical shifting. It's going to be going up and down. It's going to be the same as you would think. If it's like a plus 5, it's going to go up, but minus 5 is going to bump everything down 5. The most noticeable thing you'll see being shifted is the horizontal asymptote. Okay? It'll really affect that horizontal asymptote. You'll see that going up and down. And that A on the top is going to be our stretch or our shrink. It's going to stretch things out or squeeze them down. But the biggest thing that you'll notice from that is if it's a negative, it's going to flip everything. Okay, so this is how it would normally look. If that A was a negative on the top, it's going to flip this down to the bottom and this up to the top. Alright? So, that's how all those work. You just really need to know how they work. We're not going to really do a whole lot using those specifically. For the most part, we just need to know how to find our asymptotes and get those on the graph. And then we'll use our calculator to get some points and do the rest of our graph there. Typical problem you would have on your homework. F of x equals 2 over x minus 1 plus 2. My vertical asymptote is going to be where my x domain restriction would be. What x value would give me an issue here? I cannot have x being 1, so my vertical asymptote will be at x equals 1. The horizontal asymptote is usually at 0, but we have a plus 2, so it's going to bump it up 2 spots. It'll be at y equals 2 instead of at y equals 0. Okay, so let's get a little sketch made here, what this is going to look like. Alright, so we're going to have a vertical asymptote at 1. And a horizontal asymptote at y equals 2. Alright, so there's my asymptotes. That's going to really kind of fence in where my graph's going to go. Now I would like you to give me at least 3 points on each side. Okay, and here's how I think it is the easiest way to get these points. Okay, we're going to type this in. Y equals 2 divided by, make sure you use your parentheses, x minus 1 plus 2. Okay, most of these calculator errors, kids have been asking me questions, how come my graph looks different? It's because they didn't pay attention to the parentheses. They didn't put parentheses around that. Okay? Graph. Alright, we kind of get an idea here where our asymptotes are going to be. Looks like we're kind of in the right spot. Now how to get those points. Okay? So my asymptote, x, is going to be at 1. X equals 1. So let's pick some points just to the right side, just past 1, like 1.5, 2, 2.53, something like that. You could go to your table, second table, and go through points like that. But for these graphs, I like to use trace. So I'll push trace, and now I can just type in an x value and hit enter, and it will show me where it is on the graph and give me the y value. So just past 1, we said 1.5, enter, and you can see it jumps us over here to 1.5, comma 6. Okay, so 1.5, comma 6, 1, 2, 3, 4, 5, 6. Okay, and next little spot past 1.5 would be 2, 2, comma 4. 2, 1, 2, 3, 4. Next one's going to be, you could do 2.5, you could do 3. Alright, and by now we can kind of see, we can kind of get the idea of the curve coming down. We know we're going to be fenced in by these asymptotes. And I'm going to get really close to them, but I can't touch them. And that's going to be my top side. Okay, I can do the same for my bottom left. Remember, this was 1. I picked 1.5 and it pushed me over here. So if I go to the left of 1, I should get the points down here. So if I do 0.5 or 0, let's try 0.5. 0.5, comma, negative 2. Okay, what about 0? 0 gets me 0. And 1, oh, my fault, negative 1, gets me to positive 1, negative 1, 1. Okay, so I follow that along, and I stay fenced in by my asymptotes. I know I can't cross those. I can start getting really close, but I can't cross them. So we have a pretty good graph. Little side-by-side comparison. Not too bad, pretty good graph there of our function. Okay, why don't you hit pause and give that one a shot, and I'll be right back with you. Alright, let's see how we did. So we should have a vertical asymptote at negative 2, horizontal at negative 3. Okay, then we're going to do trace. We're going to put in some points just to the right of negative 2. Typing this in here quick and getting these points. So, like negative 1.5 would be a good starting spot just to the right of 2. We'd have negative 1.5, comma, negative 1. We can go with negative 1, comma, negative 2, and then 0, comma, negative 2.5. Okay, again, our vertical asymptote's at negative 2. So just to this side of negative 2 would be negative 2.5. Negative 2.5 would give me negative 5. Negative 3 would get me negative 4. And then if I try negative 4, it gets me negative 3.5. Okay, and we can see we have a pretty good representation here. Okay, one thing we didn't talk about yet was domain and range. Domain and range, guys, is super easy because it's right here. You've already done the work with your horizontal and vertical asymptotes. Okay, domain, we're going to use all x values except negative 2. Then we're going to use all the ranges, all the y values except negative 3. So your domain and range are very much like your vertical and horizontal asymptotes. Okay, 10 problems for homework. We got 4 of them where the book already has them graphed, and you have to answer the questions from their picture. And then 6 of them where they, just like these, where they give you the function and you have to do a graph and then answer the questions. Alright guys, thanks for watching. Hopefully this helps. Good luck!